Welcome to The Explainer. So today we're diving into a really common and, honestly, surprisingly dangerous assumption when it comes to production automation. It's this persistent idea that getting a solved CAPTCHA token is somehow the end of the story. Well, spoiler alert, getting that token is literally just the beginning.
Think about it like this. In a small, local script, you submit a task, you pull for a result, and boom, a token pops out. And that feels totally fine. But in a real, true production environment, teams need way more than just a final token. If you're only looking at that one piece of the puzzle, your engineering team is essentially flying blind. You have no idea about pending times, the types of errors happening, or, most importantly, whether your downstream system actually accepted it in the first place.
Okay, let's look at how we're going to break this down today. First, the production blind spot. Then, designing the lifecycle contract, followed by event-aware retries and scope. After that, persisting and measuring success, some common mistakes you definitely want to avoid, and finally, a few essential architecture FAQs. All right, let's jump right into Section 1, the production blind spot, and the lifecycle contract.
You see, CAPTCHA solving shouldn't just be some hidden little function tucked away in your code. It's a full lifecycle. So at a bare minimum, you really need to track events from start to finish. Things like submitted, pending, solved, failed, and of course, timeouts. But if you want a mature workflow, you've got to add in things like retry scheduled, retry exhausted, token applied, and whether it was downstream accepted or rejected. And here's the secret sauce for all of this. Every single event has to carry vital context. We're not just talking task IDs. We mean the CAPTCHA type, page URL, elapsed time, retry counts, and specific error categories. Because without a crystal clear event contract, every listener just gets totally inconsistent data, and let me tell you, debugging becomes an absolute nightmare.
Moving right along to Section 2, designing the lifecycle contract, and specifically, decoupling your listeners. So the core idea here is really simple. The solver should just solve. It shouldn't be bogged down trying to write logs or constantly ping external dashboards. Think of your solver like a news broadcaster. It's just announcing state changes to the world. And this setup allows independent listeners to handle their own specific jobs. So a logging listener records the activity, a metrics listener tracks the performance, a retry handler figures out whether to try again, and a persistence listener stores those events for later auditing. Basically, if adding a new dashboard means you have to go in and edit your core solving function, yeah, your architecture is still way too tightly coupled. That brings us to Section 3, event-aware retries and scope.
Okay, picture this. You're in the middle of a highly stressful incident review. The dashboards are flashing red, and you are frantically asking the team, what failed? Was it a timeout? Was it a bad parameter, a provider error, or did the downstream system actually reject it? If your retry logic is just some simple, isolated loop that's completely detached from the original workflow, you literally cannot answer those questions. A failed event absolutely must carry deep context, so the handler can dynamically decide if running a retry is even safe. Otherwise, they just turn into these detached zombie tasks wandering around your system with zero audit trail. And trust me, that is exactly as fun to debug as it sounds.
Now, choosing the right bus scope depends entirely on your specific operational needs. For example, an in-process event bus, like a simple Node.js emitter, is incredibly fast. It's absolutely perfect if you're running a single process application. But what happens if you have multiple workers, distributed services, or external dashboards that all need to see those exact same events? Well, then you're probably going to need an external message broker, something like Redis or Kafka. You really have to sit down and ask yourself, do we need durability, replayability, long-term auditing and cross-service access? Or do we just need a really fast local broadcaster? Let's look at Section 4, persisting and measuring success. To get this right, you have to track specific, truly actionable metrics. We're talking task submission counts, pending durations, timeout rates, and your failed counts broken down by the actual error category. You're also going to want to track solve durations, any listener errors, and the overall event volume. And a fantastic way to capture all this without slowing down your main app is by setting up a dedicated persistence listener. Just have it quietly write events to a lightweight JSON-L file or database table in the background. It basically takes this short-lived solving activity and turns it into a permanent operational history. But out of all those metrics we just talked about, the absolute ultimate measure of success is your cost per accepted workflow. Why? Because a solved token is fundamentally useless if your downstream system just ends up rejecting it anyway. That token still has to be successfully applied, and your intended business workflow actually has to complete. At the end of the day, that is the true measure of whether your automation is actually succeeding. All right, on to section 5, common mistakes to avoid.
Let's just run through a quick anti-pattern checklist, things you definitely want to steer clear of. First, please, whatever you do, do not hide your state inside one massive polling function. And don't mix up your solver logic with your logging and your business actions. Keep them separate. Also, watch out for overly short polling intervals. You really don't want to flood your logs with thousands of pending events. Try to keep that interval at 5,000 milliseconds or more. Don't retry failed tasks if you aren't preserving that original workflow context we talked about. And this is a big one. Make sure you clean up your temporary listeners when a task is done. If you don't, you are going to create massive memory leaks that will just slowly drag your entire system down.
And finally, section 6, essential architecture FAQs. First question we always get, do I always need an event bus? Well, not always. If you're just throwing together a tiny, quick prototype, direct polling is totally fine. But the second you start actually caring about robust logging, metrics, alerts, or audits in a real production environment, yeah, an event layer becomes absolutely mandatory.
Second question, can I persist these events for debugging? Yes, absolutely. Like we explored just a minute ago. Adding a dedicated listener that just quietly writes to a JSON-L file, a database, or an event store gives you this flawless audit trail. And the best part? It does it without ever touching or risking your core solving logic.
Third question, how on earth do I test this without actually calling a provider and burning through all my credits? Well, it's beautifully simple, actually. Since an in-process bus is just a standard event emitter, you can effortlessly mock your HTTP calls and just emit the events directly right inside your unit tests. That way, you verify your listeners behave exactly as expected, completely for free. To wrap things up, I want to leave you with this final thought to take back to your team. Is your automation truly completing workflows, or is it just silently failing with a valid token? Because getting that token is really just the beginning. Seeing the whole lifecycle is what actually makes your automation bulletproof. Thank you so much for exploring this with me on The Explainer today. I highly encourage you to go audit your own production lifecycle as soon as you can. Until next time, stay curious.